So we have a function, two functions. First of all, we have fx is equal to 5x minus 2 for x being greater than 1, that's the domain for fx. And then we've got gx, and that's going to be 4x squared minus 9 for x being greater than 0, so that's the domain for gx. We need to find the domain of gf. In other words, we are going to find the domain of gfx. Now, what does this function basically mean? It means that fx is going to be absorbed. Fx together with its domain is x being greater than 1, is going to be absorbed by gx, by g. So the function g takes on fx. I would say g takes on fx. So what does this imply? It implies that this domain of fx, when it gets absorbed by g, it remains, it stands. So it doesn't go away. So we have a composite function here. What is our composite function? So our composite function is gfx. So what are we saying? We're saying gf of x instead of gx. Now gx is 4x squared minus 9. So gf of x is g takes on fx, so 4 into fx minus, to the square, minus 9. Remember, this is the inside function here. It has this domain again. Right, so we are saying 4 into 5x minus 2, because that's fx, minus 2 to the square minus the 9. Now, when we look at this function here, we also have, this is our composite function, gfx. What is the domain for gfx? Domain for gfx is going to be 5x minus 2 is equal to 0, so x is going to be equal to 2 over 5. So that's our domain for gfx. But then again, this one here greater than 1, and this one is greater than 0.4. Am I saying yes, x is greater than 0? No, sorry. Am I saying x is equal to 0.4? But what happens then? The x is greater than 1, so anything less than 1 cannot be the domain of this function here, because this is inside. This domain is inside. Domain of f is in gf, in the outside function, is in gf. So therefore, strictly speaking, if I were to give my answer to this question, then I would say the domain of gf is x being greater than 1. So that's my final answer. I hope that helps. Take care.